Hello students, welcome to the online discussion of the physics paper of JEE Main 2023. This is presented to you by the Narayana Group. So in this session, we are going to discuss the memory-based questions of physics that was conducted on 25th of January, second shift. So please note this, 25th of January, second shift. Physics paper, the questions which have been collected on the basis of memory, we are presenting a solution for those questions. So look for the solutions and the important tips and tricks that are being shared for each question. Okay, let us start. All right, here is the first question. We have a wire with 5 resistors. Now it is redrawn. To increase its length 5 times, we have to find the final resistance of the wire. Now you need to understand, then it is redrawn, then the total volume remains constant. So in that case, when the length changes, area will also change. But the volume will remain same. Now we know that the formula for the resistance is R equals rho times L over A. This formula has L as well as A. And I have given the information about length. It is changing 5 times. No information about area. But as I said, since it is redrawn, volume is constant. So what we do is we multiply by L in the numerator and the denominator. So this becomes rho L square over the denominator is volume. So now rho is a constant and volume is a constant. So I can claim that R is proportional to L square. Therefore, the final resistance over the initial resistance will be equal to final length squared over initial length squared. And it is given that the final length is 5 times. So this is 5 times initial length whole squared over initial length whole squared, and that is 25. So the resistance becomes 25 times. The original resistance is 5 ohm. So 25 times of 5, 125 ohm would be the answer for this question. So third is the correct answer. All right, let's move to the next question. So that is a pretty simple question. The velocity of a particle we have to calculate. We are given the position and note the term at t is equal to 2 seconds. When we are talking about at some time t, so that means we want to calculate instantaneous velocity. So instantaneous velocity is the rate of change of position. So it is the derivative. So we have to take differentiation. So d by dt of 2t squared, and this will be 2 times of differentiation of t square, that is 2t. So 4t. So the velocity is 4t. Now put t is equal to 2 seconds. So 4 into 2, that is 8 meter per second. So 1 is the correct answer. All right, let's go to the next question. We have a particle that is performing SHM. The amplitude is A, and it starts from x is equal to 0 and reaches x is equal to A by 2 in 2 seconds. We have to find the time taken to move from A by 2 to A. This is a very common kind of question which is usually asked in SHM. One of the ways of solving this is to compare with circular motion, the easiest way. So normally what we do is we will compare the SHM with circular motion. And if we talk about a particle moving with a constant angular velocity, then as it moves from point A to point B, its y coordinate changes from 0 to A, where A is the radius of the circle. So whatever is the amplitude, you take that as the radius of the circle, and the particle is moving in a circle now. And as y grows from 0 to A, this time is 1/4 of the complete revolution t by 4. And going from 0 to a by 2 is somewhere here. This height is a by 2. So let's think of a by 2. To reach a by 2, it has to reach some point P, and this angle. Can you think of this angle? What will be this angle? So this angle is suppose theta, then this height is a sine theta, and this is given to be a by 2. That gives you sine theta as 1 by 2, and that gives you theta as 30 degree. So this angle is 30 degree. So remaining angle must be 60 degree. Now we are given that it covers this 30 degree in 2 seconds. So remaining 60 degree, it can cover in obviously 4 seconds. So answer is 4 seconds. Option 2 is the answer. All right, let's go to the next question. So in this question, we have an object of mass m, which is placed at a height re from the surface of Earth. Okay, so from the surface of Earth, an object is placed at a height h equals the radius of Earth. We have to find the increase in the potential energy if height is changed to 2re. So we know that the basic formula for potential energy is minus g m1 m2 by r. So let's take mass of Earth as m, and mass of this object is small m. So this is minus g times m small m over r. So if I talk about initial potential energy, it will be minus g m small m over initial distance from the center of Earth. So if it is at a height h is equal to re, then the distance will be 2re. And if I talk about the final value, it is height is increased to 2re. So the distance from the center becomes 3re. And we can subtract these two to find the change in potential energy. And this will be minus g m by 3re. And I have to subtract. So when I will subtract, this negative will become plus, and this will be GMM by 2RE. And when we solve it, we'll get minus 2 plus 3 over 6. So minus GMM over 6RE. Now note that answers are given in terms of acceleration due to gravity. So acceleration due to gravity at the surface of Earth is GM by R square. So that means GM can be replaced by GR square. So if I plug in GM as GR square, this becomes minus MGR by 6. So answer is option 2. All right, next question. Okay, this is a charge of 10 microcoulomb and it is placed at origin. And where should a charge of 40 microcoulomb be placed on x-axis such that the electric field is 0 at x is equal to 2? So let's draw x-axis. We have a charge of 10 microcoulomb placed at origin, x is equal to 0. We want to place a 40 microcoulomb charge so that the electric field is 0 at x is equal to 2. So at x is equal to 2, we want electric field to be 0. Now this 40 microcoulomb charge will generate an electric field towards right, E. So I want to cancel this field, so I will place the other charge of 40 microcoulomb at some x so that it produces an electric field in the opposite direction, let us say E prime, so that the net field becomes 0. So if this is x, this distance would be x minus 2. Now E will be k into 10 microcoulomb over 2 squared. and E prime will be K into 40 microcoulomb over x minus 2 whole square, and we will set E equals E prime. So once I set E equals E prime, I will get 10 over 4 is equal to 40 over x minus 2 whole square. So that gives you x minus 2 whole square is equal to 16. So take the positive square root because we know there is only one possible answer and x has to be positive. We already decided that. So x minus 2 is equal to 4 and therefore x is equal to 6. So answer is 3, option 3. Okay, let's go to the next question. So we have a diagram that shows different transitions of electron between the energy levels, and energies are mentioned along. And we want to find the transition which will generate a photon of wavelength 124.1 nanometer. So we want to obtain the wavelength 124.1 nanometer, and we know the energies. We know that energy difference must be equal to hc by lambda, where lambda is the wavelength of the photon. So lambda will be hc over delta E. Now value of hc in SI unit is given to us, not in SI unit, in electron volt unit. So you note that lambda is also in the nanometer and hc is also in nanometer. So delta E will come in electron volt when I plug in the value. So delta E is hc over lambda, and that is 1241 electron volt nanometer divided by lambda, which is 124.1 nanometer. So this clearly gives you delta E is equal to 10 electron volt. Now you have to check which transition is corresponding to a difference of 10 electron volt. So this is 0, this is minus 10. So the transition from D to ground state. So this one is the answer. Right? Let's go to the next question. We have two straight infinite wires placed parallel to each other, and they are carrying currents of 8 ampere, 6 ampere, carrying current in opposite direction. Okay. And we have a point P which is equidistant from the wires. Equidistance means each of this distance is 7 by 2 centimeter, and we want to find the magnetic field at P. So the basic formula involved is infinite wire magnetic field, which is mu naught I by 2 pi r, one thing. Second thing you need to talk about is direction. You have to be very careful about direction. So the 8 ampere wire, as the current goes up, if you grab it in your right hand and apply the thumb rule, so the field lines around it would be like this, and it will be going cross here, dot here. So this 8 ampere produces a cross field here. Now let's talk about the 6 ampere wire. The 6 ampere wire is going down. So if you grab it in your right hand and apply the thumb rule, the field over here will be cross, it will be dot. So field due to both the wires are cross, so they will be added. So mu naught I by 2 pi r, I1 and R1, and similarly mu naught I2 by 2 pi R2. So we can fit in the values over here. We know that mu naught by 2 pi, let's take common, and I1 by R1. 8 over R1. R1 is 7 by 2 centimeter plus R2. R2 is, sorry, I2 6 over the distance 7 by 2 into 10 to the minus 2. And we can solve this value, and this answer will finally come out to be 8 into 10 to the minus 5 Tesla. So option 1 is correct. Fine, let's go to the next question. Okay, this question is about an LCR circuit, and we are given XL. XL means we are given the reactance of the inductor, we are given the reactance of the capacitor, and the resistance. We want to find the power factor. Power factor of a series LCR circuit. Power factor is cos phi, and it is R over Z. If you don't remember this formula, remember the impedance triangle. This angle is phi, and this base is R, this is Z, and this is the reactance XL minus XC or XC minus XL, whatever could be the case. So power factor is cos phi. Why power factor is cos phi? Because power is EV, IV, cos phi. Since power consumed in a circuit depends on cos phi, so we call cos phi as the power factor. So R is given to us as 80, and Z will be square root of R square plus XL minus XC whole square. So it will be square root of 80 square plus 130 minus 80, 50 square. And this value will come out to be 8 over square root of 89. So that is the value of cos phi. So the power factor is 8 by root 89. Okay, next question. Okay, this question is calculating about moment of inertia. We have a disk and a solid sphere of same radius. Okay, radius is given to be same, and their masses are different. We have to find I disk by I solid sphere. Okay, so moment of inertia of disk about this axis. So this axis lies in the plane of the disk. And to find the moment of inertia about this, we need a parallel axis theorem. So first we will write the moment of inertia about a diameter of the disk. And for a disk, the moment of inertia about diameter is mr square by 4. So that means this must be, by parallel axis theorem, mr square by 4 plus mr square, which is 5 by 4 mr square. Similarly, for a solid sphere, the moment of inertia about the center is 2 by 5 mr square. This distance is r. So by parallel axis theorem, this will be 2 by 5 mr square plus mr square, which is 7 by 5 mr square. Masses are different, be careful. Now when I have to write the moment of inertia of the disk and the moment of inertia of the sphere, so it will be 5 by 4 mass of the disk into r square. R is same for them, and this is 7 by 5 mass of the sphere into r square, and you can put in the values of the sphere mass and the disk mass. So this will be 5 by 4 times 4 is the mass of the disk, and this is 7 by 5. Oh, the data is very nice. So this 5 and 5 cancel, 4 and 4 cancel. Answer is 5 by 7. So option 3 is the correct answer. Right. So let's go to the next question. Oh, that is a very pretty straightforward question. Two projectiles are fired at an angle of projection alpha and beta, and alpha plus beta is 90 degree. So alpha plus beta is 90 degree. That means complementary angles, na? And we remember that for complementary angles, range is same. If you don't remember, let's look at the formula. So R is U square sine 2 theta over G. So first we are projecting it at angle alpha. So sine 2 alpha over G. And in the second case, we are projecting it at angle beta. So sine 2 beta over G. Now beta can be replaced by 90 minus alpha. So if I replace beta by 90 minus alpha, this is twice of 90 minus alpha by G, which becomes U square sine of 180 degree minus 2 alpha by G. And sine of 180 minus theta is again sine theta. So therefore, this becomes U square sine 2 alpha by G. So the two range are going to be equal. So first is the answer. Okay, let's go to the next question. We want to find the molar specific heat capacity for an isochoric process. So we want CV, and of a diatomic gas, and we want vibrational mode also taken into account. So the molar heat capacity is F times R by 2, where F is the number of degrees of freedom, There will be 3 translational degree of freedom. And for a diatomic gas, we have 2 rotational degree of freedom. And for each vibrational mode, we get 2 degrees of freedom due to vibration. So it's 7. So CV is 7 R by 2. So answer is 3. Next question, we have a block which is placed on a rough inclined plane with 45-degree inclination. Okay. And it is given that the minimum force to push the block up is 2 times the minimum force required to slide it down. So first we want to move it up, we will write the minimum force, then we want to slide it down, we will write the minimum force, and then we will compare it. So it is given that the force required to move up is 2 times the force required to move down. Okay, when it is trying to move up, the force of friction will act downward. So we know that mg sine theta will act in this direction, mg cos theta will act in this direction, normal will be here, and force of friction will be mu n. So the force required to move it up will be mg sine theta plus friction, and friction will be mu mg cos theta. So this is the force required to move it up. Now let's talk about the second case when we want to move it down. So when I want to move it down, then I'll apply a force downward. And if it slides down, you have to understand that the force of friction will change its direction. So if it is able to slide down, the downward force must be at least equal to the upward force. Therefore, the force required to move it down will be mu mg cos theta minus mg sine theta. So now we will solve for this equation. So we have mg sine theta plus mu mg cos theta. This must be equal to twice of mu mg cos theta minus mg sine theta. And that gives you mu is equal to, okay, let's solve for it. This will be equal to 3 mg sine theta is equal to mu cos theta. So mu is equal to 3 tan theta. And theta is 45, tan 45 is 1. So the answer is mu is equal to 3. So mu is equal to 3. So option 4 is the correct answer. Okay, let's move to the next question. Okay, so this question number 13 is about matching the dimensions. So let's match the dimensions. So I will look for the easiest one. First, work function is the easiest one. Work function is energy, minimum energy required. So energy is, you remember, if you don't remember, let's think of a formula, half mv square. So half is dimensionless, mass m, L T minus 1 raised to power 2. So this is ml 2 T minus 2. So this matches with D. First, I will see R has a D. Okay, this one is D. Array, luckily, I got the answer in the first option only. So second is the answer. But still, for your knowledge, I will match up with the others also. Let's talk about Young's modulus. So Young's modulus is stress by strain, and stress is force over area. Strain is dimensionless. So it is force over area. So force is mlt minus 2 divided by area L2. So this is ml minus 1 t minus 2. ml minus 1 t minus 2. So this is B. Yes, this is correct. Then let's talk about coefficient of viscosity. So coefficient of viscosity, if you don't remember the formula for coefficient of viscosity, then let's think of some formula. I know Stokes law, F is equal to 6 pi eta RV. From here I can find the dimensional formula for viscosity. F over 6 pi is dimensionless, R into V. So the dimension of force divided by dimension of length and dimension of velocity. I would recommend you solve it. The answer will come out to be C, ml minus 1, t minus 1. Being a teacher, I remember this data. And for Planck's constant, obviously the last one is left. Still, let's go for Planck's constant. So for Planck's constant, I remember Bohr's quantization principle, MVR is equal to n times h over 2 pi. So n is a number, so no dimension, 2 pi has no dimension, so angular momentum. So h dimensional formula is same as angular momentum, which is mass into velocity is lt minus 1 into another length, so ml2 t minus 1. So that is for the Planck's constant. So this goes with A. Although if you would have seen intelligently, then just by looking at the option R, we could find the answer. All right. So this is done. Next question is on the same page. So I'll clean this up to solve the next question for you. There is no need to clean. I guess we'll have space. Just this much cleaning is sufficient. Okay, a big drop is divided into 1,000 identical droplets. And we want to find the ratio of initial surface energy to final surface energy. Now, surface energy is surface tension into surface area. And surface area will be 4 pi r square for a single drop. So this is initially, gamma is surface tension. If you want to write final surface energy, finally there will be 1,000 droplets into surface tension does not depend on the size, it will remain the same, into 4 pi r square, where r is the radius of the each final drop. How to find the radius of the final drop? So we will conserve the total volume. So 1,000 drops, each of radius small r, are equivalent to a single drop of radius capital R. So if I take cancel 4 by 3 pi and take the cube root, I will get r is equal to 10r. So we can plug in this value over here, and then we can divide ui and uf. We'll get the answer. Answer will be option 3, 1 by 10. So u finally will be 10 times basically, because when I put r as r by 10, so this value becomes 10 times of the initial value. So therefore this ratio will come out to be 1 by 10. Okay, next is again a matrix match type question. Very interesting, simple question. All you need is to remember certain laws. So Faraday's law is related to electromagnetic induction. So it matches with S. Array, again, luckily I chose the one which gives me the answer directly. So option 2 must be the answer. Still, we'll verify. Ampere circuit law is about line integral of magnetic field. So this is Q. Gauss law is about calculating the surface integral of field and put it equal to Q by epsilon naught. So this is R. Gauss law in magnetism is integral B dot ds is equal to 0, because magnetic field lines always form closed loop. So the surface integral of magnetic field, the total flux is always 0. So this is P. So RQPS. This is the correct answer. Okay. Next question. So we have a stationary nucleus that breaks into two daughter nucleus having their velocity in the ratio 3:2. We have to find the ratio of their nuclear sizes. So now this question is based on two concepts. First is the conservation of linear momentum, and the second is knowing the fact that mass of a nucleus divided by volume of a nucleus, that is the density of nucleus, and the density is a fixed value. So different nuclei have same density. So mass is directly proportional to volume, and volume is proportional to r cube. So volume sphere we can assume, so mass is proportional to r cube. So these two concepts we are going to use. So we have a stationary nucleus, so initial momentum is 0. It breaks into two nuclei having masses m1 and m2, velocity in the ratio 3 is to 2. So one of them will have velocity 3v and the other one will have velocity 2v. So from here I can write m1 over m2 is equal to 2 over 3. So R1 over R2 cube is equal to 2 over 3. Therefore, R1 by R2 will be equal to 2 by 3 raised to power 1 by 3. So 2 by 3 raised to 1 by 3. So second answer. Okay, let's move to the next question. Now again a matrix match type question. So let's see first the options. Which one is only coming one? So B has A, B, Q will be having B, C, A, D. So I'll look at the options. Q has B in this, C in this, A in this, D in this. So if I look the correct answer for Q, I'll get the correct answer in the first step. So let's go for isochoric process. So let's match it up. Isochoric process means volume is constant, and if volume is constant then dv is 0 and work done is p dv, which is 0. So this should match with A. So Q should match with A, and therefore I know that third must be the correct answer. Still, let us verify others. This is just for the examination hall. When you are in examination hall, you can save your time by looking at this. Okay, let's go for the adiabatic process. Adiabatic process means no heat exchange. So C is the answer. Isobaric process. Isobaric process, pressure is constant, volume will change. So whatever heat we supply, some part of it is converted to internal energy and some is going into work. We know that dq is equal to du plus pdv. And isothermal process, temperature is constant, and if temperature is constant, there will be no change in internal energy. Internal energy is a function of temperature for an ideal gas. So all others are also matching. Okay, let's go to the next question. Okay, we have a circuit, the current in the 4 ohm resistor connected through A and B. 4 ohm. Okay, so we want to find the current in this. All right, so there are two ways of solving. One is the laborious method of using Kirchhoff's law. You may write some current here X, some current here Y, and current here as X plus Y, and then write the equations of KVL. And but actually this is a straightforward question. This is a direct formula based question. If you remember that formula, if you don't remember, I'm writing it here, so it is an interesting result to remember. So if we have two cells connected like this, then they are in parallel and they can be replaced by a single cell of EMF E1 by R1 plus E2 by R2 over 1 by R1 plus 1 by R2, and they can be replaced by a cell whose internal resistance is 1 over R is equal to 1 over R1 plus 1 over R2. So in that case, the circuit will finally become like this, and we can find the current. So let's first find E. E will be E1 means 5 by 3 plus 8 by 4 divided by 1 by 3 plus 1 by 4. So this will come out to be 44 by 7. 5 4s are 20, 8 3s are 24, 44 by 7 volt. And when I calculate R from here, R will come out to be, let's solve for R, it will be 1 by 3 plus 1 by 4 inverse. So it will be R1 R2 by R1 plus R2, 12 by 7. All right. Now this R is 4 ohm. So we can straight away find the current E by R plus R in this circuit. E is 44 by 7 divided by R is 4 and small r is 12 by 7. So this is 44 by 7, 7 4 is 28, 40, 44 over 40, and that is 1.1 ampere. So the current is 1.1 ampere. all these are memory based questions, so some data may be different from the actual one because of the memory. Maybe you don't remember the exact data, so we are solving it exactly based on what information we have. Okay. All right, the next question, 19th, we have a metal rod of length 1 meter and it is moving perpendicular to its length. So this is a rod of length 1 meter and it is moving perpendicular to its length with a velocity of 8 meter per second. And this length is 1 meter. And we are given a magnetic field 2T perpendicular to the plane of the metal. So 2 Tesla magnetic field is there and we want to find the EMF. So EMF, if BV and L are mutually perpendicular, then EMF is straight away BVL. So it is 2 into 8 into 1. So it is 16 volt. So answer to this question is 16 volt. Okay, let's move to the next question. Okay, somewhat calculative question. First time the entire paper I'm seeing a bit of a calculative question. In this arrangement shown, we have a lens. Some object is placed at a distance x. Then behind 20 centimeter there is a mirror, and it is shown that a final image is formed behind the mirror at 5 centimeter. The image is formed after refraction from the lens and reflection from the mirror. Focal length of the lens is given. Length of the lens, actually it should be focal length. So we want to find x. Okay. So let's do the reverse. So mirror is forming an image 5 centimeter behind. We know that for a plane mirror, object and image are equidistant. So this distance must be 5 centimeter. Now this O is actually the image found by the convex lens. So for the lens, here is the object. I don't know this distance x, and the image of the lens is this 20 minus 5, 15 centimeter. So we will take U as minus x, V as plus 15, and focal length is 10 centimeter, and we'll apply the lens formula. The lens formula is 1 over V minus 1 over U is equal to 1 over F. So we have to calculate U. So 1 over V, okay, let's plug in the values first. So V is 15, U is minus X is equal to focal length is 10. So 1 over X is equal to 1 by 10 minus 1 by 15. And this will give you X as 15 minus 10, 30 centimeter. So the value of X will be 30. So they have already mentioned the unit. So all you need is to write 30. Okay, next question. We have a capacitor of capacitance 5 microfarad. Now the medium between the plate is air, the capacitance is 5. Now we are inserting a dielectric to fill half of the separation between the plates. Area same, we want to find the new capacitance. Okay, again, this is a very popular formula based question. This is area of the plate. This is the plate separation D. And when we insert a slab of thickness T in it, the capacitance becomes epsilon naught A over D minus T plus T by K. And when nothing is there, so capacitance is epsilon naught A over D. So the value of epsilon naught A over D is given to us as 5. And we want to find this value. So let's solve for this. And we are given that it is filled in half the separation between the plates. So T is given to be D by 2. So this is epsilon naught A over D minus D by 2 plus T is D by 2 and dielectric constant is 1.5. So this is epsilon naught A over D minus D by 2 is D by 2 plus D by 3. D by 2 plus D by 3 will be 5 D by 6. So this is 6 by 5 times of the original value. So the answer is 6 microfarad. So we have to fill in 6 because microfarad unit is already given. So 6 is the answer. Okay. Next question. We have a particle of mass 1 kg and it is moving with the velocity. We don't know the velocity, okay, towards a stationary particle. So this is a particle of mass 1 kg, and it is moving with certain velocity which we don't know. There is a stationary particle of mass 3 kg. After collision, the lighter particle, lighter means the first one, the lighter particles, the 1 kg particle returns along the same path with the speed of 2 meter per second. We don't know what happened to the other particle. Its speed is not given to us anyways, but we are given the information that collision was elastic. Then we have to find the speed of the 1 kg before collision. So this value we want to find. So let's call it u. We want to find this u. So for elastic collision, we have E is equal to 1, which is the velocity of separation over the velocity of approach. So velocity of separation, I need to assume this value as v. Velocity of separation means relative velocity in this case, which is v plus 2. And velocity of approach is relative velocity in this case, which is u minus 0. So we get v plus 2 over u is equal to 1. That is one condition. Also, when simple these kind of collisions are there, we assume that there is no external force acting, so momentum must be conserved. So initial momentum 1 into v plus 3 into 0, and final momentum is minus 2 into 1 because it is going to the left, plus 3 into v. So wait just a minute, 1 into u. So I get u is equal to minus 2 plus 3v. Also, we get v plus 2 is equal to u. So v is 2 minus u. I'll plug in the value. U is equal to minus 2 plus 3 times. V is u minus 2. So this gives you 3u. 2u is equal to, this is minus 6 minus 8, 8. So u must be equal to 4 meter per second. So that is the velocity of the particle before impact. So 4 we have to value, and it is already given. So 4 meter per second. Okay, that is the end of the question paper. These are the questions which were available with us based on the memory. So we have presented you the solution. I hope the session was useful for you. Keep watching for the next papers and upcoming JEE main paper solutions. Thank you.